Augmenti! Augmenti! Stupid thing. Augmenti!
Harry, what are you doing?
I'm trying to put this fire out with that spell.
What, with Augmenti?
Yeah.
The one that we learned in spells class?
Well, where else would I have learned it?
Harry, that's a terrible spell. I swear it only works half the time, even for me. Harry, would you like me to show you another spell?
There isn't another spell.
Of course there is. Professor McGonagall told me that we can use Muggle chemistry to come up with new spells.
Muggle chemistry? Really?
Yes.
What
it's an elective, Harry. You grew up with Muggles, you should know.
You would take that for an elective.
Harry, do you want me to help you or not?
Yeah.
All right, then come with me.
You grew up with Muggles too.
Okay, Harry. We're going to use Muggle chemistry to come up with this new spell, all right?
All right.
All right.
Wait.
What?
Muggle chemistry, AP potions. They're at the same time. How are you taking both electives?
Gosh, Harry, how many times do I have to tell you? I can be in two places at once.
I always forget. I'm not really used to this whole magic thing yet.
It's okay, you'll get there. All right, so, look here. Professor McGonagall showed me...
I need to get my reading glasses.
Okay, Harry. Better?
Yeah, I can see.
All right. So, look here. Magnesium hydroxide. That's a compound. A compound. It's made up of different elements that come together to form one compound.
Okay.
Okay. It has magnesium, hydrogen, and oxygen.
Yeah.
All right. Professor McGonagall told me that this is a flame retardant.
A what?
A flame retardant.
That's not a nice word, Hermione. Come on.
No, Harry. That means that it stops fires.
Oh, I need to say so.
Because I like to use intellectual words, Harry. All right, just follow me here, all right? Look, it's a flame retardant that we can use to put out fire. So that means that we can use this compound to make your spell. Okay. Okay?
Totally.
Harry, do you understand what I'm saying?
Yeah, I think I get it just fine.
Clearly, this is going to need some further explanation. Come on, Harry. Okay, Harry, listen to this. Magnesium hydroxide is a flame retardant that tries to inhibit or delay the combustion of materials, mostly plastics. To stop the plastic from burning, the magnesium hydroxide undergoes an endothermic reaction that results in solid magnesium oxide and water vapor. The magnesium oxide residue looks like a black char that acts as a coat covering the plastic. This char is doing two things. First, it is preventing flammable or toxic elements that would perpetuate combustion from escaping the plastic. Secondly, it is insulating the plastic, preventing the outside heat from infiltrating the plastic and causing further combustion. Meanwhile, the water vapor that is released into the air dilutes flammable gases, depleting the fire's fuel. The effects of the magnesium oxide char, insulating the plastic and preventing the release of flammable elements, in combination with the water vapor diluent, help to delay or stop the burning of the plastic. There are many practical uses for magnesium hydroxide. It is commonly used in products such as vinyl siding, thermoplastic olefin roofing, and low-loading wire and cable insulation. It could also potentially be used in other polypropylene products like kettles, storage bins, and food containers that won't melt in the dishwasher or the microwave. So, with so many options like aluminum hydroxide and various halogenated flame retardants, why do manufacturers choose to use magnesium hydroxide in their products? For starters, magnesium hydroxide has a very high point of decomposition at 330 degrees Celsius and a high melting point of 350 degrees Celsius. These are significantly higher than the decomposition and melting points of its competitor, aluminum hydroxide, which decomposes at 230 degrees Celsius and melts at 300 degrees Celsius. Thus, magnesium hydroxide is better able to withstand the high temperatures used in the process of making these products. Moreover, manufacturers also favor magnesium hydroxide because it does not contain halogens. Halogenated flame retardants contain elements from the halogen group, specifically bromine or chlorine. According to the National Center for Biotechnology Information, upon decomposition, these flame retardants release toxic chemicals into the environment that are associated with harmful health effects in animals and in humans, including endocrine and thyroid disruption, immunotoxicity, reproductive toxicity, cancer, and adverse effects on fetal and child development and neurologic function. Magnesium hydroxide provides an excellent alternative to these harmful flame retardants because the products of its decomposition are friendly to the environment and its inhabitants. Furthermore, the flammability of a material can be measured using a scale called the Limiting Oxygen Index, or LOI. The value of an LOI tells you the minimal amount of oxygen that must be present in the air by percent volume of the air in order for a material to burn and sustain a flame, however small that flame may be. Typically, the air is comprised of about 21% oxygen by volume, so materials with an LOI less than 21 are considered to be quite flammable, seeing as the amount of oxygen they require to combust is almost always present. Materials with an LOI between 21 and 28 are considered to be slow-burning materials, and materials with an LOI of 28 or higher are considered to be resistant to flame. So basically, the higher the LOI, the more resistant a material is to combusting. Manufacturers look at the LOI of potential flame retardant additives and choose the ones with a high LOI value of above 28, such as magnesium hydroxide. Additionally, one of the many benefits of magnesium hydroxide is its smoke suppressant qualities. According to the National Fire Protection Association, heat and flames are not always the most dangerous part of a fire. The leading cause of death during a house fire is actually smoke. The fire uses up the oxygen during combustion, reducing the amount of oxygen available to people for respiration. This can lead to internal damage and a series of other problems. As mentioned before, the air is typically comprised of 21% oxygen. When that percentage drops to 17%, people will experience impaired judgment and coordination. At 12%, they will start to experience headache, dizziness, nausea, and fatigue. At only 9% oxygen, you are likely to lose consciousness. When there is only 6% oxygen, the situation becomes critical, with respiratory arrest and cardiac arrest, which can lead to fatalities. Magnesium hydroxide, however, is a great smoke suppressant because it slows and even stops combustion, leaving more oxygen available for respiration, and it dilutes the smoke, making it less likely for you to breathe in harmful particles or toxins. So, if you put together all the components of magnesium hydroxide, its efficient endothermic decomposition, harmless byproducts, smoke suppressant qualities, high limiting oxygen index, and its broad range of applications for various products, magnesium hydroxide proves to be a very effective flame retardant with realistic applications and benefits.
All right, Harry. With everything that we know about magnesium hydroxide, I think that we're ready to make your spell.
Yeah, I think so too. What should we call it?
How about magnesium hydroxide?
Okay. Magnesium hydroxide.
No, Harry, magnesium hydroxide, not magnesium hydroxide.
They sound the same.
They're not the same. Are you ready to test it out?
Fine.
All right, let's do it.
Alright, let's see if this works. Do you remember how to say it again? Oh. Magnesium hydroxide. Oh, awesome.
Harry! It worked! Our spell worked!
Yeah, why you sound so surprised?
Well, because you were involved. But I have to say I'm surprised. Good work, Harry.
Thanks, Hermione.